when we're running some code in real time, it always happens that it will end up in some errors which we may not predict. So that time, if you want to make sure that program doesn't halt, then we use a concept called exceptional handling. What it will do is, it will just catch that error and hold it, and it will continue further execution without terminating. So let me show you one example to understand this. Let's say I have I is equals to string apple, okay, and let me print I, and we get the output apple, nothing fancy. Now by mistake, if I type int of a string, which is not really possible, okay, you can actually convert floating point into an integer, but you cannot convert a string to an integer. If you try to do it, what happens is it will throw an error. If you observe carefully, there is an error which is generated over here, and anything after that, that is not executed at all, right? Now if you want to avoid this situation, what you could do is you could add something called as a try. Now try is a block, therefore we give the colon, and because we are starting a block space, we need to give the indentation, and we have a method to catch the exception called except. Again, it's a block, so colon, then here I'll say some error has occurred. Okay, now you run it, we're able to catch the error, some error has occurred, but I think this is not being printed. Why name I is not defined? Yeah, so here what we'll do is I'll give I equals 0 initially. Yeah, now perfect. Now here you see that here we are trying to do an operation, but it failed, therefore it didn't stop, it went over here, it printed. After that it continued the program and it printed, and because I is last having a value 0, that is being printed. So that's how you can catch the errors so that the program does not halt abruptly. So this is a very basic try and except. So it's very similar to try catch in other programming languages. Now here we could see that there was an error, right? So let me redo it one more time. If we say I is equals to int of apple, you run it. If you look at the trace, you can see that this is a format value error. It says that invalid literal for int with base 10 for the string apple. So this is a message given by the interpreter, right? So this message you could actually show it to the user. So what we could do is, if you know what type of error it could generate, you could actually specify that specific error. Something like, let me copy this, let me put it over here, try indentation. So let's remove this. Here we know that it will generate an error, so except. Now in the bracket you can specify the error, so I'll say value error, and then I'll print there is a value error. Now you run it. This time the message is more clear, there is a value error. Now what if you want to specify the exact message given by the interpreter? Now what we could do is we could remove this brackets and then say value error as E, and then you could give the exact message E. You run it, and this time you see the message given by the interpreter. Let me show you one more frequently seen error. Let us say I have I is equals to 10 divided by 0. Any guess what could be the error? So we have 0 division error. So here what I'll do is, you can add any number of except blocks. So let me add one more except block, and now let me say 0 division error as E, and then print E, and here let me give 1 divided by 0. Now you run it. This time we see division by 0 error. Perfect. Now for the try and except, we can also add else. Now what is this else is, if none of the exceptions have been raised, then this else block will be printed, something like your finally keyword. So let us say all is well, and here let's give 10. So I is equal to 10, an assignment, no error. So this also should be printed. Let's try. Yes, we get all is well. Now coming to the error reporting, sometimes if you want to specify that there is a possibility of an error, we could use the concept of error reporting through a keyword called raise a specific error. So for this, let me show you one example. Let us define a function and let's take some variable arguments. Okay, now let me take L, which is the length of the arguments. What I'll do is, if the length of the arguments is less than 1, that means if you do not specify any argument, then I want to raise an error. So to raise the error, we say rise, and what type of error? It's a typing error. So type error, and I would say a custom message that arguments cannot be less than 1. Perfect. Okay, if at all the arguments are less than 1, then it will raise. Otherwise what we'll do is, for I in arg, I'll just print all the arguments given. Great. Now let's use it try and except. So in the try, let's call the function and let's pass 10, 20, 30. Here let's say, here we have a type error, right? Type error as E, and then I'll print, let's use an F string, and let's say type error and the error message. Perfect. So as of now, because we have passed the arguments, there won't be an error. It actually has to print all the numbers. So you run it, you can see that 10, 20, 30 are being printed. Now if I don't give any arguments, then I run it. Now you see there's a message which says that there's a type error, and the error is arguments cannot be less than 1. So that's how you could report to the user or the programmer that this sort of an error is happening. So you need to change the arguments and then you rerun the program. Great.